Okay, so I would like to talk about which dogs are faster. Okay, so this is kind of super long run stuff, okay? Do not try to do any of this crap in the short run. It does not tend to work, okay? So this is, I'm talking about things that happen really, really long term, not things that happen in the immediate, okay? So there are some categories of functions, and I just want to spit them out fairly quick. So there's log functions, right? Those are things like natural log, and I'm going to put x's in here. Log base 10 of x, log base b of x, where b is bigger than 1, for instance. So I do want to say that when I talk about logs, I'm not talking about logs with negative bases or bases smaller than 1. Bases are always going to be bigger than 1 whenever I talk about logs here. Cool? Okay. There's also exponential functions, right? It's an exponential function. Yeah, some kind of number to a power, right? Where the variable is in the power. So that's functions like e to the x, 2 to the x, 10 to the x. These are the ones that get used fairly often. There's lots of others. Pi to the x is, oops.
Pi to the e, that's great.
Yeah, pi to the x is one of these. Careful of that one. This is not one of these.
Not an exponential.
Yeah, this is a power. This is a composite exponential function. Don't do this one. This is a tower of powers. Well, I'll mention them in here.
Tower of powers.
Yeah, so
Sounds
A
intense.
power to a power.
Tower of power.
And you can get really big.
yeah, so I'm gonna just lump that off on the side. I hadn't intended to talk about these, but sure, let's add them in there. Okay, so those are also things. If you put more variables in here, that's also something I would call a tower of powers. So functions like x to the x to the x are also, these things are nasty, nasty business. So I want you to, mostly what I want here is just a word of warning. If you see one of these things, it's probably not modeling reality in any way. It grows way too fast.
Because I've seen one like 3 to the power 3 to the power 3 is like 7.6 trillion or something.
Yeah, if you do this even with relatively small numbers, these things get enormous fast. These are extremely good for overloading buffers in computers. So if you want to shut the RAM off on a computer, just fill it with one of those. Ask it to calculate to 10 or something, and it'll die. Okay, so beyond sabotaging computer hardware. We have logs, we have exponential functions. I'm going to assume that the base on these is bigger than 1. So it's going to be like b to the x for b is also bigger than 1. That goes with the 1 for logs. Right? That's cool with that? So these are really exponential, maybe growth functions. What's an exponential decay function look like?
With a negative exponent?
Yeah, so you could think about that as a horizontal flip of one of these things, right? Really, a horizontal flip here is going to amount to a function like e to the minus x, or 1/2 to the x, right? That's the one we usually use, or similar kinds of things. Notice here that on e to the minus x, the base is really, this is really 1 over e raised to the x. You guys cool with that? Okay. Then further, we have polynomial things, which you guys know a definition of. That's like ax to the n plus some garbage. Cool. And then root things. So root things are square root of x, cube root of x.
Can we just like write that as a number to a fraction power?
Sure, yeah, you could really think of polynomials as variable to power bigger than 1. That's not really the case, right? They have to be natural numbers bigger than 1. But you could really think about it as power bigger than 1. And these guys you can really think of variable to power
Fractional power.
bigger than 0 and smaller than 1. That's cool with that? I'm not putting rational functions in here because I just don't want to deal with it. In the long run, they can be basically polynomial or root or several other things. Cool. So I'm just going to leave those out of this discussion. But the idea is which of these grow the fastest as I send x to infinity. So as x goes to infinity, so I guess I may as well just put my y-axis over here. I'm not going to talk about the other side of that.
So we're just talking about absolute values.
Yeah, we're just talking if you hike way out right, which of these get biggest fast. So I just want to list the order of these dogs in with no precision at all. So the things that get the biggest the fastest are the towers of power. Those get enormous super, super quick. Okay? And I'm doing a disservice to how fast these grow by drawing that arrow at all divorced from the y-axis. Like, if you zoom out at all, these may as well be the y-axis. They're extremely, extremely quick. Cool? Notice this one's not defined at 0, but like I said, we're only talking about really big x's, right? All right, what's the next fastest thing on this business? Yeah, exponential growth is probably next fastest.
Well, growth and decay would be the same thing if we're talking about absolute.
Yeah, so I'm only talking about outright. So if I go outright, exponential decay is going to 0, right? So that one's going to kind of quash out fairly fast. That's going to be my last thing here because it's not really growing, it's decaying. So exponential growth things might look like this. They're also really actually steeper than that. What's my next thing? Yeah, polynomials are kind of next. So polynomials are going to grow something like, oops, not like that. Grow something like this. They will never outstrip that exponential growth. They might cross it in the beginning or something, but they'll never outstrip it in the end. You guys see what I mean by that?
Yeah.
Like this line might look like this. But it's always going to be the slower dog in the end. Okay. Then what's next?
I'd say root thing.
Good. Root things. Totally. So root things are going to go like, right? They're going up. They're just not going up very fast. And the rate at which they're going up is going down. That makes sense? Those dogs get tired. These other ones, they just get invigorated by running. Right? Like the further they go, the faster they're going and the faster they're accelerating. Cool? So they're just digging deeper all the time. This dog is actually a real dog that gets tired. What's next? Yeah, logs is next.
The whole dog.
Logs are log dogs, yeah. These are dogs that need to stop and eat and stuff. Okay, so logs grow super duper slow.
After a trillion units of time, they got 12 units of distance.
Yeah, exactly. Right? Log base 10, right? This one counts the zeros on a number. So it's got to go 10 times further to get another 1 unit of increase. Will it get to infinity eventually?
Why is
Like,
it infinite zeros?
Will it pass any particular number? Yeah, eventually. Does it take a hell of a long time to get there? Yeah. You guys with me on that? Like if you're using log to count things, about the most you can get to is 350. I think we believe that there are definitely less than 10 to the 350 particles in the universe.
I thought that number was like 10 to the 80 something.
Sure. Yeah, it doesn't particularly matter, right? It's not that big when you take the log of it, right? It's like 80 or 400 or whatever. Cool? All right, so then what's my slowest thing? Well, the slowest thing is the one that's not growing at all, right? It's decaying. And those look like this. Yeah. So that's it's still, right? It's still not actually zero, right? But it's not going anywhere. You guys see that?
Yeah.
Cool. Questions, Niels? So the most important of these is this comparison between exponential growth and polynomial growth. Exponential growth is always faster than polynomial growth. It should be noted that populations grow with exponential growth and food production grows with polynomial growth. That is actually a scary thing.
So we'll never have enough food? Really?
Unless you curb this, right? Unless you stay out of exponential growth on your population, you're never going to be able to feed it, right? Eventually it'll outstrip. You guys see that? That is an eventually, right?
Yeah.
So right now humanity is in okay shape on feeding most of us. Not willing to say good shape because, you know, whatever. But at least we're kind of okay on that. If the population continues to grow exponentially, which it has been, then maybe we'd have a problem. Cool. What else grows exponentially that you guys know of? Bacteria in a petri dish? Sure.
Still a population.
There's one more thing that you guys know of that grows exponentially that you use every single day.
Technology.
Yeah. Tech grows exponentially as far as we can tell. There's this thing about the number of transistors you can cram on a microprocessor, that it doubles every 10 years. And this is held true for the last 30? That's not right. I got my factors off on that.
But
And
can
the cost
electricity be
of the-
considered a linear line, so we only have so much power, so eventually we're not gonna be able to power the thing that we could hypothetically make?
Well, efficiency is a thing that's growing too.
Yeah, efficiency is a thing that we're improving too, and it's possible that efficiency is one of these.
Well, we do have transformers.
That's
Like
part of
giant robots,
efficiency.
like-
Yeah, that's part of efficiency. Not transformers. Transformers don't grow at all as far as I can
Oh, I know.
tell. They don't seem to reproduce.
But if you don't have enough power.
Do they? I don't know. Someone should ask that question about the
It's like the
Transformers
number of
franchise.
transistors
They must reproduce,
grow
right?
exponentially per dollar you spend on it too. Like,
Yeah, so another thing that grows exponentially is money.
Yeah, definitely.
So these are kind of worth knowing, right?